Bayesian reasoning's power to challenge religion and empirically justify atheism. Now, as you probably already know, Dr. Carrier is the author of numerous books and articles, including Sense and Goodness Without God, On the Historicity of Jesus, and The Scientist in the Early Roman Empire. Now, he teaches several affordable online courses in philosophy and history every month. He has a PhD in ancient history from Columbia University. He also specializes in the modern philosophy of naturalism, the origins of Christianity, and the intellectual history of Greece and Rome. If you'd like to learn more about Dr. Carrier, visit www.richardcarrier.info. And if you would like to be personally taught by Richard Carrier, you can actually go online and get some of his courses. If you go to the right side of your screen under the section that says offers, you can actually click and check out any one of his 8 courses, and you can take them at any time. So I highly recommend that you take a look at the offers section being promoted right now. Click on the link, and you can go and attend some of his courses. Now, I'd love to emphasize just one of his more recent books, On the Historicity of Jesus. Now, this book has made ripple effects and waves throughout the academic world. And in this book, Dr. Carrier actually challenges the assumption, the bona fide, the given that historical Jesus researchers have given that says Jesus of Nazareth was an historical figure who really lived in first century Palestine. Dr. Carrier challenges this and says instead that Jesus may have likely been a celestial being instead, somebody who was known only through private revelations and hidden messages in scriptures, and that eventually stories about this celestial being were then put into an earth setting to give an allegorical way of communicating claims the gospel and that celestial being. And then, of course, later on, these allegorical stories were taken literally. If you haven't read this book, it is incredibly influential and powerful. I highly recommend it. I would love to introduce my good friend Richard and say thank you so much for being here. The floor is yours, sir.
Yeah, thanks for having me. Well, welcome, everyone. So I've only got half an hour to do a quick explanation of what I'm going to talk about today. There is a handout. If you look at the files box on the right of your screen, you can download basically a handout that kind of summarizes some of the stuff I'll talk about today, but it also has a ton of bibliography, like useful links and articles and books and stuff that are on this subject, which is applying Bayesian logic to critical thinking in general, but more specifically today, I'm going to talk about religion and atheism. So what is Bayesian logic? Well, it began over 200 years ago. Thomas Bayes, after whom it's named, figured something out. What he figured out was that the probability of everything, no matter what you're talking about, comes down to arguing about really just 3 numbers. How likely something usually is, and how likely the evidence you have is if your explanation is true, and how likely that same evidence is if your explanation isn't true. And with those 3 questions of probability, you can actually explain all valid arguments of an empirical nature. Anything that is argued from evidence is explained this way. And that's because not only does all empirical reasoning reduce to that fact, it does so because all empirical reasoning is about a probability. It's all discussing that. And so today I'm going to quickly show you how you can use this information to critique religion and defend godless naturalism as well as the most credible explanation of everything that we know. Just half an hour today, but I discuss this more extensively and take all possible questions on it beyond the half an hour Q&A we'll have after this today in several online courses that I teach. In particular, my course on critical thinking, my course on counter-apologetics, how to address religious arguments, and my course on historical methods for everyone, which is about how to reason about history. And the key thing here is that everything is a probability. When we say we know something or that some claim about the world is true, what we really always mean is we know that that thing is so very probable that we can trust that it's true. In other words, it's being false is so very improbable that it isn't reasonable to expect it to turn out to be false. So we just operate as if it's true. And every argument or question about what exists, what's true, is really an argument or question about a probability. So it's all probabilities, and probability is math, unfortunately. Some of you are scared of math. I promise the math is super easy today. I will not get into very heavy math at all. But the point is that if we're talking about a probability, if we're trying to figure out what is the probability of this claim being made, or the alternative explanation of the same evidence, that means we can turn to Thomas Bayes. We can go back to his idea and use what he learned to try and analyze these arguments and see where they might go wrong or how we can make them go right. Now, probability itself is a modern invention of specialized notation. Psychologists have found that human intuition, our brains, are inherently made to understand probability more when stated as odds. So, for example, you say 1-to-1 odds. It's equal chance that it's going to happen or it's not going to happen. Whenever you say 50-50 odds or 50-50 chance, you're basically saying 1-to-1 because 50 divided by 50 is 1, so it's 1-to-1. Or if it's 2-to-1 odds or 1-to-5 odds or whatever, the chance of something happening, our brains more intuitively understand it when we think in those terms. Or we can think in chances. So, for instance, there's a 1 in 3 chance it'll rain today, or a 1 in 100 chance that I'll get into a motorcycle accident, or 1 in 1,000 chance of this, or 1 in 1 million chance of that, and so on. Similarly, our brain works with that more similarly, more easily than putting things in percentages. So I'm going to use the odds form today. And in fact, I'm going to teach you right now all the math that you need to know, which is not much. So what I'm going to do is I'll bring up the whiteboard. And if you go around, say 50-50, let's say you're starting your claim, you have no information that the claim is more likely true. You have no information that the claim is more likely false. As far as you know, it's as likely true as false. So you say it's 50-50 chance that what I'm saying is true or not. And that actually, you can just reduce to 1-to-1 because it's 50 over 50 is the same as 1-to-1. And then let's say you come along and you find some evidence. And the evidence is twice as likely to exist if your expectation is true. Let's say you're talking about it's going to rain tomorrow. It's 50-50. Normally, the odds in this particular season is 50-50 on any given day that it'll rain. But you get some information about some growing storm clouds or whatever. You see that when you see that, that's twice as likely to occur when it is going to rain tomorrow than when it's not. So now you have 2-to-1 odds. You started with 1-to-1. Now you've got these clouds. They're twice as likely to exist if it's going to rain. So now you've got 1-to-1 times 2-to-1, and that's just 2-to-1, right? 1 times 2 is 2. 1 times 1 is 1. And it doesn't matter what numbers are. That's how the math works. If this was a 3 and this was a 2, it would be 3 times 2. It would be 6. And if on the bottom, same thing. So that's really it. All we're going to do is odds, and it's just simple math like that. So getting back to where I was. Now, this is the easiest way to talk about probabilities. So I will only use the odds form of Bayes' theorem in this presentation. And if you've downloaded the handout, you'll see a simple statement in there. You should think of Bayesian argument as like any other logical argument. It just follows a simple formula. Don't even think of it necessarily as math. It's just logic. And the basic state, you can restate it simply as this. The final odds that a claim is true equals the prior odds that the claim is true times the odds of the evidence on the claim being true rather than false. So there's just two statement of odds. One is what is the prior odds and what is the evidential odds. And when you multiply those together, you get the final odds, which is just basically the probability that your claim is true or false, depending on how you've organized it. So you can simplify it to just prior odds equals evidential odds times the final odds. And that's final odds on the claims being true. But the prior odds times evidential odds equals the final odds. So what are the prior odds? What do we mean by that? That's the outcome of countless previous calculations of the final odds. So probably done intuitively your whole life. You've not done this math consciously. Your brain just did it for you. And for humanity, across generations of humanity, the same thing. Prior odds are how things have turned out usually. And that's like weather reports. When you say like in this season, prior examples, prior evidence shows that every other day it rains, so it's 50-50 chance it's going to rain on any given day. That's a prior odds. And then when you get evidence that might change your mind about this particular day, that can change it. And that would be your evidential odds that I just gave you an example of earlier. And that just updates your prior odds, gives you the final odds it's going to rain tomorrow, or anything else, any other claim. It doesn't have to be a prediction. It can be whether the claim is true or false, and so on. And that's the point of prior odds, is that it's what has usually turned out to be the case, what things usually continue turning out to be. It's based on your past experience. It's based on evidence, but it's all the past evidence of other cases. So, for instance, if when we reliably investigate a miracle claim, if when we do that, we always discover that it was a fraud or a mistaken impression or misreported or something like that, if it always turns out to have been some non-miraculous explanation, and we do this 1,000 times over the centuries and always find the same result, then we can logically say the odds against the next miracle claim being true are 1,000 to 1 against. That's an example of prior odds, and it's based on evidence. It's not made up. It's not something that we just conjured out of air. It's based on the fact that prior cases over centuries, in many, many cases, that's how it's turned out. So it's 1,000 to 1 at least against the miracle claim turning out to be a real miracle, as opposed to what it's usually turned out to be on prior examples. Now, of course, that just gives you the prior odds. What if you've got really special evidence for this one miracle? Maybe this is the one time we're going to prove that a miracle is real. Well, that you start with the prior odds and you have to multiply it by the evidential odds. How good is your evidence for this? So what are the evidential odds? That's how much more likely is the entire collection of all the available evidence that we have if the claim is true, rather than if the claim is false, or how much less likely, depending on which way the evidence goes. So, for instance, if the evidence is 10 times more likely to exist if the claim is true than if the claim is false, then our evidential odds are 10 to 1, right? It's 10 times 1. Or is it 2 times less likely? Then it would be 1 to 2. Or it could be only slightly more or less likely. It could be 99 over 100. There's lots of different ways you can state it depending on what it is. How likely is this evidence if the claim is true versus how likely is this evidence if the claim is false? And that ratio gets you your evidential odds. And this your brain is doing intuitively all the time. This is how you're always evaluating evidence. Your brain is doing this math for you. Your brain is doing the prior odds calculation. Your brain is guessing on the evidential odds, and it's sort of roughly ballparking the result for you. And that's how you reason most of the time about evidence, when you're reasoning evidentially. So that's, again, if it's 10 times more likely, evidential odds are 10 to 1. Since 10 is 10 times 1. If it's 2 times less likely, then the evidential odds are 1 to 2, since 2 is 2 times 1, and so on. Now, the prior odds are important here. You can't ignore them because we can't ignore history, right? Our conclusions about what's plausible now are based on a vast body of accumulated past evidence, and we can't ignore that evidence. And so this gets us to my first example, which is what we would call the argument to naturalism, or just the naturalism argument. And that's, I'm going to sort of roughly sketch it out. You can get much more specific and careful about it, and I do in some of the writings that are linked in the handout. But to put it simply, over thousands of years, there have been millions of claims that have been made that things in the world are caused by supernatural powers, gods, and the like. From lightning and crops growing to individual miracles, communications from gods and spirits, and so on. Magic, everything. We've had millions of these claims. And every single time any of those claims actually got reliably investigated, it turned out to be the reverse, that the cause was mindlessly natural or humanly contrived, which is also just as natural. That has happened over time and time again is what has built our prior odds heavily against the supernatural at this point. It didn't have to turn out that way. We could have found ourselves in a world like Harry Potter's or Middle-earth or any superhero universe that you want to imagine, where the supernatural is a matter of routine. You find it everywhere. The more we fail to find the supernatural in a world, the less and less likely it is that there is any in that world. And we just so happen to have found ourselves in a world where there so far hasn't ever been any. So there probably isn't any. That isn't saying there definitely isn't any. It's saying there probably isn't any. And that conclusion is based on evidence. It's based on centuries, thousands and thousands of accumulated cases of it always turning out one way and not the other. It didn't have to turn out that way. It could have turned out the other way. We could have had a lot of evidence for the supernatural by now. We just don't. Now, if someone wishes to contest that now, after all that accumulated evidence over centuries, the burden is now on them to prove some supernatural phenomenon probable. Not merely a logical possibility. We accept that. They have to prove that it's an actual appreciable probability. And that's a lot harder, because we have already met our burden showing otherwise. With the entire history of science and investigation, we have a vast mountain of evidence that we're sitting on. That meets our burden. If you want to go against that vast mountain of evidence, you've got to have a pretty big mountain of evidence yourself. So that's why it's important to talk about it as probabilities rather than possibilities. The debate between the supernatural and the natural is always about what is more probable given the evidence. And that's why we call supernatural claims extraordinary claims. And you know the statement, extraordinary claims require extraordinary evidence. It's often applied to claims of the supernatural. The reason we say that supernatural claims are extraordinary is because that's how the evidence has turned out over centuries. The supernatural claims are extraordinary claims in precisely the same way and for precisely the same reason that natural explanations are not extraordinary claims, because they quite typically turn out to be true. And that's just the way it's turned out over there. And that evidence stacks up. It has an effect. So Bayes' theorem actually explains why we are right to be skeptical of supernatural claims now, and why science is right to assume explanations are going to turn out, yet again, to be natural. Anything we haven't explained yet, odds are it's going to be some natural explanation, because that's how it's turned out millions and millions of times before. So Bayes' theorem doesn't just do that. It also explains the logical validity of several principles we count on a lot in critical thinking. For example, I just mentioned extraordinary claims require extraordinary evidence. That's actually correct. And as we said, the very phrase extraordinary claim means a claim with extremely low prior odds. Let's say 1 in a million against. To say it's extraordinary is saying it just isn't the sort of thing that ever turns out to be true when thoroughly or reliably investigated. So let's say, again, let's say it's 1,000,000 to 1 against. Then we could say a claim that has turned out to be true no more often than 1 in a million times is extraordinary. Then extraordinary evidence means that the odds of the evidence on the claim being true rather than false must be just as large or larger. So if the evidence we have is 1,000,000 times more likely to exist if it's true than if the claim is false, then we'll get that extraordinary evidence. And I'm going to show you how that looks again in notation here. So if we have the extraordinary claim is 1 in a million against, and we would need to reverse that around. We would need evidence that is 1,000,000 times, my writing is terrible, 1,000,000 to 1. And then you multiply those together and you'll get 1,000,000 over 1,000,000, right? Which would be just reduced to 1 to 1, which would get you to even odds. Even odds that the supernatural claim is actually supernatural, that it actually is true. So you actually need better evidence than this, right? You need something more than that. So let's suppose we have 1 in a million against. I'll just write 1 in a million against. And you have evidence that's 2,000,000 times more likely to exist if a claim is true. And that's some really extraordinary evidence, right? And then you would end up with 2 to 1, right? So then you would end up with 2 to 1 odds that this actual supernatural event actually occurred. So you actually can prove miracles. You just need really, really good evidence that is so improbable unless the supernatural is actually happening. And that's what we never find, right? That's in 200,000 years, 200 years, 2,000 years. We've never found an example of any evidence for a miracle that was anywhere near this good. But that's what you need. You need some extraordinary evidence like that to actually turn things around. So, and again, like I said, any evidence more than that, if it's 1,000,000 to 1 against, you need evidence that's 1,000,000 times more likely. If you get that stuff, you need more evidence than that to get it more and more probable. But any less evidence than that, if the evidence isn't that good, then you just can't get the claim to be probable at all. There's no logically valid way to get the claim to be probable other than to get this evidence that has extremely low probability of existing unless the claim is true. That's just the only way you can ever get the probability up. And this is actually what we always mean intuitively by evidence being strong or weak, or evidence at all, right? It increases the probability of a claim being true. That's what we mean by evidence. If the evidence is strong, we're saying that it really increases the probability by a lot. If the evidence is weak, we say it's increasing the probability of the claim only a little bit. If it doesn't increase the probability of the claim at all, then it's not evidence for that claim. And so that's how we actually operate intuitively. And so what I've just done is I've popped the hood on your brain and shown you the math that your brain is doing. And now that you know that, you can actually tinker around and actually use this and correct perhaps when your brain is intuitively going wrong, or when someone else is doing so. So Bayes' theorem has given us a way to logically validate the entire concept of evidence. Strong evidence is, by definition, evidence that is very much more likely if the claim is true than if it's false. It's evidence, in other words, that's very unlikely unless the claim is true. Weak evidence is, by definition, evidence only slightly more likely if the claim is true than if it's false. And if the evidence is just as expected, whether the claim is true or false, if it's equally likely, both it being true, both being false, they both expect the exact same evidence. If the evidence is just as likely either way, then we have odds of 1-to-1, equal odds on the evidence, regardless of whether the claim is true or false. And if you did that, if you show that in a thing, let's say you have prior odds. Let's say your prior odds are 1-to-2 against, and you have evidence that's equally likely whether it's true or false. If you do that, you just end up with the same prior odds as your final odds. This evidence did nothing. It did not increase or decrease the probability of your claim. And so you need evidence that has a high value up top, right, over the value below. Your x needs to be high and your y needs to be low. This is if the probability of the evidence, if it's true, the probability of the evidence if your claim is false. And that's just the only way to do it. Logically, that's the only way to get a claim's probability up. And so, once again, any value multiplied by 1 remains unchanged. So that kind of evidence, the evidence, if it's 1-to-1, it's equally likely on both possibilities of the claim being true or false. That kind of evidence is useless. And so now we know the logic behind why it's useless. That's how we know the evidence is useless. And we know what it takes now to make evidence useful, to make it actually do work, to increase the probability of a claim. So another example of a principle we often rely on that Bayes' theorem explains and validates is the argument from silence, right? So we know sometimes the absence of evidence isn't evidence of absence, but we also know sometimes it is, right? So how do you tell the difference? How do you know the difference? Well, the difference is when the missing evidence really is expected to exist, then its being missing is improbable because it's unexpected, and that's just another word for improbable. Unless the claim is false, then you fully expect there to be no evidence, right? If the claim is false, the evidence is entirely what you expect it to be. There to be no evidence of it. So this gives us a disparity in evidential odds. So if we go back in here and we see, we start with prior odds, equal chance your claim is true, 1/1. And you have missing evidence that you don't expect. And let's say it's 5 times more likely that you wouldn't have that evidence if the claim is true than if it was false. Or we can do it that way. But you would end up with 5-to-1, right? So what you need is evidence. When there's absence of evidence, for absence of evidence to be evidence, you need to expect that evidence to exist. So it's if you can explain it away, for example, if you invent the idea that there were invisible ninjas that came along and destroyed the evidence, then of course your odds are 1-to-1. Now there's a reason why that doesn't work. I'll get to that in a moment. But you can at least get to the point where now we expect the evidence to not exist, whether it's true or false. It's equally likely to not exist whether the evidence is true or false because it was destroyed. And if you could prove that it was destroyed, then you would be able to say this validly. So that's when argument from silence doesn't work. When the argument from silence does work is when the evidence is missing, being missing is very unlikely. So for example, if there were only a 1 in 10 chance that the evidence we expect would be missing, that's a 10% probability, right? So it's a 10% chance that that evidence would be missing, even though the claim is true. But if the claim is false, it's 100% that we would not have that evidence. And of course, 10/100 is just 1 over 10, right? You reduce it. So the odds against your claim are 1 in 10. 1 to 10, actually. So if your claim started 1 to 1, and you have missing evidence that you should have, you end up with the probability of your claim being true of 1 in 10. So you've gone from 1 to 1 to 1 in 10. The probability of your claim is dropped precipitously because there's evidence missing that should be there. And there's no good explanation for why that evidence isn't there. So that's when arguments from silence work. So that's when the absence of evidence in this case really is evidence of absence. But again, if we fully expect the evidence to be missing, then it won't be, because the probability of the evidence on both being true and false is exactly the same. So it doesn't increase the probability of your claim at all, or decrease it. So now all of the same stuff, that's how we can work with the argument from silence. Use Bayes' theorem to figure out when is an argument from silence effective and when is it not. And it's all based on how expected is the evidence to be missing. If your claim is true versus how expected is that result if the claim is false. Now, all the same goes for Occam's razor. You know, Occam's razor is really popular. That is more or less the idea that the most likely explanation of something is the explanation that requires the fewest made-up things to work, to get it to work. Like when Newton explained the motions of the planets with a single force, gravity. Adding the additional supposition that angels are also pushing the planets along violates Occam's razor. And the point here is it's not that it's simpler to eliminate the angels. The point is that there's no evidence for the angels, and you don't need them to explain the motion. So let's turn around and take all of this stuff up and apply it to some arguments for God. So let me get rid of this. Actually, I'm going to put this in. So let's say we're talking about probability that God exists. Now, really, we start out with very low probability that there are supernatural disembodied ghosts, supernatural powers, right? That's what we'd say normally. We'd start with very low odds. But let's be super kind and say there's 50-50 chance there's a God. And then we come along and you see a Christian give the fine-tuning argument. And their fine-tuning argument is the physical constants of the universe are so finely balanced that had to be intelligently arranged that way. And so what they're saying is that the evidence is, let's say, 1,000 times more likely if it was designed than if it was chance. Chance accident is so unlikely. It's much more likely if it was designed that it would come out that way. So that's what they're arguing. So they're trying to say, I'm making up the 1,000, but let's say they're saying 1,000 to 1 chance that God exists because of fine-tuning. Well, the problem is that they're leaving evidence out. When you put evidence back in, you end up with a different result. So what is the competing explanation for chance? So we're 1 out of 1. What are these two things? The first one is God did it. The other one is chance accident did it. If chance accident caused the universe to be the way it was, what should we expect? We should expect the universe to be vastly old and vastly large and to be almost entirely full of stuff deadly to life. And it is. You know, it's mostly lethal radiation-filled vacuum. It's mostly gigantic nuclear bombs and black holes. Almost the entirety of the universe is lethal to life. It's actually almost as lethal to life as you can get a universe that still has life in it. Even planets very rarely are hospitable to life. Like, this is a really, really badly designed universe for life. It only is just barely able to produce life at all, which is what you expect if you're going to pick universes at random, right? If you pick universes at random, you're never going to observe yourself in a universe that can't produce life. So the probability of that is 0. You're only going to observe yourself in universes that can produce life by chance. But those universes, most of those universes, thousands and thousands, trillions to 1, most of those universes are going to be mostly inhospitable to life. They're going to be mostly like this universe, vastly old, vastly huge, and almost entirely lethal to life. So the evidence actually looks exactly like what we'd expect if chance is the explanation, right? Chance actually explains the evidence. The evidence is actually more likely on chance than on God. Because God doesn't need a vast age of a universe. He doesn't need a vast, huge universe. He doesn't need a universe that's almost entirely inhospitable to life. Like, that's not what you would expect on God. You can make up excuses, but those excuses are going to reduce your prior odds because you're adding things that you don't have evidence for. Remember, that's Occam's razor. You're violating it. You're adding stuff that you don't have evidence for. That only makes your claim less probable, not more probable. So that doesn't help. So what you get is the evidence of the universe altogether looks like chance accident caused it. So that the chance accident hypothesis actually has better evidence for it. So we actually have The fine-tuning argument actually is evidence against the existence of God, because only atheist universes require fine-tuning, whereas godless universes don't. God doesn't need to fine-tune constants, right? He can just make a universe behave the way he wants it to behave. It doesn't have to do any fine balancing. Whereas only godless universes have to be finely tuned. There's no other way to get life except by this chance arrangement. So we expect fine-tuning on atheism 100% of the time. Every single atheist in every single godless universe will observe fine-tuning, because there's no other way to exist and observe anything unless the universe has been finely tuned. And if that's the case, so atheism expects this, whereas you don't expect it on God. Like, it's very weird for God to need to finely tune a universe and then do it so that the universe that results is almost entirely inhospitable to life. So this is how you can actually turn arguments and evidence around. You actually start with the original Christian claim, the argument, put evidence back in that they left out, and then the Bayesian argument, the evidence flips the other way. The evidence becomes very improbable if God exists, but very likely entirely what we expect even if God doesn't exist. And so if you keep doing that, and you can do this to every argument. I have one of the links in the handout is to Bayesian counter-apologetics, and I give 10 arguments for God, and I show when you apply Bayesian reasoning to it and put the evidence back in that Christians left out, it flips the odds the other way, so that actually becomes evidence for atheism. And I want to make a final point with this, is that I am actually saying what you think I'm saying. I'm not saying that atheism is justified because there just isn't evidence for God, and therefore atheism is a default position. I'm saying that the evidence actually argues for atheism, that we can actually make a positive empirical case that there is no God, because that's where the probabilities stack up. They stack up only in that direction and not in the other one. We could have had a more ambiguous state of affairs, more ambiguous set of evidence, but we don't. The evidence looks pretty strong. You look at every single argument from consciousness, argument from religious experience, even the cosmological argument. You just go item by item. The evidence, when you put it all back in, looks more like a godless universe, exactly what you would expect of a godless universe, in fact, and not what you expect on an argument from design. And then, so what theists will do when you point this out is that they'll try to make up excuses for why God built a universe that looks exactly like the universe would have to look if there was no God in it. But by doing that, all those assumptions that they're adding, each one of those assumptions is improbable on itself. So their improbability just stacks. All those improbabilities add up, and then the prior odds just go down and down and down. And I illustrate how this happens in my article on Bayesian counter-apologetics and in some other areas like that. So this is just giving you the gist of how you would do Bayesian counter-apologetics, why this is an important tool. Once you understand that you're talking about prior odds and evidential odds, now you know what to look for. You need to look for the evidence that's been left out. You need to ask, is that the evidence we would expect on these different hypotheses? And what evidence would we expect on the godless hypothesis? Like, actually ask, if there was no God, what would we expect to observe? And is that what we expect to observe on intelligent design? And usually the answer is no. And so I find this a very innovative and useful tool. It can be applied to everything, not just counter-apologetics. That's just the topic I'm covering today. And if you want a lot more detail on this, like I said, I teach online courses every month that cover this, where you can ask all the questions you want, see more examples, go more in depth, cover more arguments and more ways to use Bayesian reasoning. And that's my presentation for today. So I think we'll go to Q&A after this and see where we go from there.
Dr. Carrier, thank you so much for this. This was an excellent presentation. It was a great breakdown and quick summary of a Bayesian theorem, Bayesian reasoning. What's interesting, what I particularly liked was the ad hoc rationalizations that can come up when discussing stuff, right? So it's and how that actually lessens the probability that of your.
That's I didn't have time to really illustrate that, but that's one of the innovative things that Bayes' theorem has taught me, and I think can teach anyone, is that you always know there's something going wrong when they're doing that. Like, they make up all these excuses, and you know they're pulling one on you, but you're not sure logically why what they're doing is invalid, right? Like, but Bayes' theorem explains why it's invalid. Because once you start adding suppositions for which you have no evidence, like, well, God has a certain attitude or certain plans. Like, well, what evidence do you have that that's how God thinks? Well, I don't have any. It's like, at best, it's 50-50. So now you have to rely on an assumption that's 50% likely to be true, not 100% likely. And so your probability goes down by half because you're multiplying it by 50%. So you've already reduced the probability that your God exists before you even got into the evidence. And then what happens is the benefit that it creates, the ability to explain the evidence, is not enough. Like, the more assumptions you have to add, your probability, your final odds go down. They don't go up. So that's the thing, is like, once you realize that this is how empirical reasoning works, making up excuses to get something to fit evidence against it is a surefire way to lose the argument, because what you're doing logically actually requires the reduction of the probability of your claim rather than the increase as you intuitively think. And that's, I think, an important discovery for this.
Absolutely. Now, you're arguing that you are, in fact, being able to prove that atheism is true, basically. You can prove empirically that there is no God.
Yeah, in the soft sense of proof, right? So you only ever end up with a probability. It's not like we can conclusively, mathematically, logically prove that naturalism is true. It's that odds are it's true. I mean, that's and there's a lot of evidence. You can stack up the evidence. The same as anything else in science and history. We never know anything for certain, but we can. The more we add evidence, the more that probability goes up. And once it gets to a certain point where there's just no sense in even expecting the thing to be false at that point.
So what I'd like to do is explore some of the counter arguments that would go against your position and how you would respond to that. But before we go that direction, why do you think if your math, everything is so clear and obvious that you have the higher probability, why is it not accepted as a given?
Yeah. I mean, the reason, that's cognitive science, really. Humans do intuitively do what I'm talking about, but most of our beliefs are emotion-driven. They're desire-driven rather than evidence-driven. In fact, basing your beliefs on the evidence is counterintuitive. It's not how we've evolved to act. So it actually takes a lot of work, and it's uncomfortable and difficult. Whereas if we just naturally flow along the way that nature designed us, most of our beliefs are based on what we want to be true rather than what actually is true. And once you have that desire belief link, it's very hard to break it, because that generates motives to rationalize the belief. So most of what people do when they think they're critically thinking is they're really just trying to rationalize what they want to be true. They're trying to make up reasons why it should be true. And that's how you get the cherry picking fallacy. You go looking for evidence that validates you, but you don't go looking for evidence that would actually invalidate your position. The counterintuitive method that we've learned, and this is what the Greeks first discovered, is that you need to stop doing that. You need to you need to deliberately try to disprove yourself and take that seriously, not try to do it in an easy way, but you try to find a real test that would actually genuinely prove you wrong if you were wrong. Go take that test, and by failing to prove yourself wrong, that's the only way you can actually prove yourself right. It's the only way, and you can show this in Bayesian principles. You can show it's the only way to get the probability of your claim to be up. The only way to increase the probability of your belief is to try to prove it false and fail, because what you need is evidence that is very unlikely if your claim is false, right? So you need evidence that's very unlikely unless your claim is true, and you need that disparity between the probabilities of evidence of it's being false, evidence of it's being true. And to get that, you have to go looking for evidence against your claim. And so that's counterintuitive, but it's the only way to actually do this successfully.
So basically, the argument is, look, it's a pretty surefire bet that naturalism is true. The reason my argument isn't accepted is because of confirmation bias, basically. People are going to seek out evidence.
I mean, not just confirmation bias. If you, I recommend everyone go to Wikipedia and type in list of cognitive biases. They have a great page with hundreds of cognitive biases. That's all the ways our brains are badly designed. Literally every single one of those is a malfunctioning design feature of our brain, which shows you why brains were not intelligently designed. They're crap. They're really terribly engineered. And there's tons of these things that make our reasoning go wrong. And we have to actually make a conscious effort to install firmware and run it to get around that. It's science, logic, all that stuff is it's a software patch to try and fix all the broken hardware in our brain. And the broken hardware is way more than confirmation bias. It's tons of biases. We're just littered with junk. And so it's worth looking at just to be overwhelmed by how badly designed our brains are. And also to know, when you go through that list of cognitive biases, to know what you need to be doing to fix that, right? What you need to be doing to control for the ways your brain makes mistakes. And you have to do that consciously. So you have to know what those things are and how to beat them, like how to get around them. And then you have to actually do it, right? So it's like, it's not enough to know how to do it. You can know how to do it and then just never use the ability. So you have to, it's several steps and it's a lot of work. And whereas if you don't do any of that, well, it's going to be desire-driven belief system and you'll be impervious to evidence, basically.
So let me ask then, an obvious counter argument against you from theists would be something along this line, that the numbers that you're ascribing to the probabilities are oftentimes very arbitrary, especially when we're dealing with miracle claims. Because you are trying to figure out what prior probabilities are of an event that has never happened before, it's very arbitrary that you're even sticking a number on it. So as an example, the burning bush, Moses in the burning bush. So how would you be able to ascribe any probability to that?
Yeah, so you reference Classett, right? And this is something I talk about in Proving History in my book. Because it's incorrect to say that there's just one claim. That's actually part of a whole genre of claims, right? You can come up with a million. Each one is individual. Maybe it's a burning bush one time. Maybe it's you met a golden man another time. Maybe it's you see angels in the sky another time. These are divine communications involving some sort of miraculous aspect. There's millions of these kinds of claims across all religions, across all of history. So it isn't just one time. It's millions of times. And never once when we actually investigate these claims and we're actually allowed to go check if they're true, every time we do that, we find that they end up not being true. They're either the story was made up or it was misinterpreted or it had a natural cause or whatever. And that's why the prior odds are so low. It's because we have checked these things. Now, we didn't get to check the burning bush that one time, but there have been tons of these kinds of claims that have been checked and they turned out not to be true. And that's why everybody's skeptical of these things. It's the same, Christians do the same thing. If a Scientologist comes along and says, "Hey, I spoke to Xenu," their first go-to is like, "Oh, that doesn't happen," right? Because it's like that. Their assumption is like, no. People have psychological experiences. They convince themselves that these things happen. They know what's normal, right? They know what's extraordinary and what's not. It's just when it's their belief, suddenly they throw away all of their background knowledge and make an excuse for themselves. But that's the key to that. And there are ways to do it. So you have, and one of the things you brought up is the arbitrariness of the probabilities. They're actually not so arbitrary, and I talk about this in Proving History. And the key thing is that you want probabilities that are as far against what you're saying as possible. So, I think it's probably billions to one against a supernatural claim being true, but I'm willing to say it's 1,000,000 to 1 just to give them a shot, right? Because I can easily show that we have more than 1,000,000 instances, or have had throughout history, of claims being made about the supernatural that turned out to be natural rather than supernatural. And all throughout science, all throughout history, all throughout cultures, all throughout different religions, countless examples. And so we know it's at least 1 in 1,000,000 against. It probably way worse. But you can argue, it's called arguing a fortiori. It's granting as much as possible to your opponent. So that they can't really argue that it's better than 1 in 1,000,000. If they want to argue it's better than 1 in 1,000,000, then they need to go prove it, right? Go find some actual examples of miracle claims that turned out to be true once thoroughly investigated, right? And then you can compare, well, now it's 5 out of 1,000,000, because we have 5 examples here and there's probably about 1,000,000 there. They need to actually find examples. But if you don't, you end up with a calculation that, there's another calculation by Laplace called Laplace's rule of succession, where you can calculate what are the odds given the fact that you haven't seen it 1,000,000 times out of 1,000,000. 0 out of 1,000,000 can still give you odds. It actually comes out to be 1 over 1,000,000 to 1, or 1,000,000 to 2. 1 over 1,000,000 to 2. There's actually math for this. So these aren't really arbitrary. They're based on evidence, but we're just going so far against what the evidence would actually indicate that you really can't argue with it. Unless you do. But to do that, you have to do it with evidence, right? You can't just declare the prior probability of a miracle is 1 in 3. If it was 1 in 3, then 1 out of every 3 miracle claims would have been proven true by now. So you can't claim it's 1 in 3, right? So what can you prove? That's the question. What evidence do you have that the odds are higher than that? And that means you have to go back to the evidence. Let's find an example of a miracle claim that's been proved out. That's where you run into the weeds, or the theists run into the weeds. Is once you start talking about evidence, then your probabilities don't look so arbitrary. They start to look reflecting the actual correct intuition about things.
Now, so let's talk about presenting evidence and whether it's even necessary in some cases. One of our attendees, Dr. Robert Benton, comes in, has a good point to make. If I were to come to you in just a normal conversation and say, I had a dream about my brother last night. Do you really need evidence, or would you take me at my word for it, right? And most people would probably take me at my word for it. Why can we not do that with some other things like religion?
Yeah. This is another good example of prior odds, right? Like we have a vast database. We've been alive in the world. Humanity has been alive in the world for generations. We've got tons of books on dreams and stuff like that. So we know dreams are normal. They happen a lot. So the prior odds that when someone says they had a dream, they really did. If we lived in a society where people lied all the time about having dreams, and we knew that, like we'd accumulated 100 years of accumulated evidence of this culture, these people just always lie about dreams, then we wouldn't take it for granted. Then we would be suspicious. Yeah, you guys usually lie about dreams. But that's not what happens. We know that when people talk about dreams, they usually have the dream, and so it turns out usually to be the case. That's what we would need to do the same thing for supernatural. We would need it to usually be the case that supernatural claims turn out to be true and investigated. That hasn't happened, right? So unlike dreams, unlike people's claims about dreams, which frequently and routinely turn out to be true, claims about the supernatural don't. And so it's the past evidence has turned out differently for those two things. And that's why we do this. There's more subtleties to that, as theory of other minds and complexities of the epistemology behind that, dreams and whatnot. But that's generally how we do things. We're talking about what is usually the case, and you can even reference yourself. When I talk about dreams, I'm not usually lying, so why would I assume this person is? And it's that kind of thing. And there's lots of other evidence you can look at that indicates that people are telling the truth about their dreams. And so you have all this evidence. So you can actually make this argument. That doesn't mean that they never lie about their dreams. Maybe 1 out of every 1,000 times they do. But that just means that the odds will flip the other way. It's 1,000 to 1 instead of 1 over 1,000,000, right? So it's the opposite. We just don't have this evidence for the supernatural. We have the opposite evidence for the supernatural. So things turned out differently, and that's why the odds come out differently.
Well, this kind of broaches into, reformed epistemology, Plantinga's stuff, right? But when
I hate that stuff. But yeah, go on.
Right. So what you're talking about is there sufficient evidence for you to believe that I dreamed about my brother last night? But if we flip it and we say, I don't have any evidence that I present, empirical evidence that I dreamed about my brother last night, but I know I dreamed about my brother last night. Yeah. So I have enough evidence that that the dream did occur.
Yes,
you may not have enough, but I have enough to believe it.
Yeah, true. I talk about this in Proving History too. Disparities in evidence are sometimes unresolvable. Because if you're an eyewitness to something and someone else isn't, you have information they not only don't have but can never get. They have to rely on a report. And so that does change people's perspectives. But when it comes to the supernatural, we can actually internally analyze this. Like when someone says, I saw something and it was supernatural, and says, well, all you really have is that you saw something. You don't really know what caused that vision or that appearance or whatever. So what all they can really attest to is what they actually experienced, not what caused it. What caused it is always an inference. So they're in the same boat we are in terms of determining what caused their experiences. And so there is a way that supernaturalists can't use that as an argument to try and prove the supernatural, because all they can do is say, well, this is what I saw. And I'm saying well, I have an alternative explanation for why that's what you saw. Just prove it, right? What's the evidence? What usually turns out the case? And usually what turns out to be the case is that when someone claims to have seen that, they were being tricked or they were mistaken, or whatever. The variety, or they're lying. That also happens as well. But notice, like with the dream thing, like if you come to me and say, I had a dream about my brother. If I were to be a true skeptic of, or a radical skeptic of that and say like, well, I don't know, I don't have any evidence whether that's true. I am literally saying that there's a 50% chance that you're lying about the dream. Or maybe you have a false memory of having had a dream, although that gets into the question of, is there a difference between a false memory and a dream? But that's a really bold claim. That's not a neutral claim at all. To say that there's a 50% chance that you're lying or somehow deluded, that's a really high probability, right? So why am I so confident that that probability is so high when I have all this vast body of evidence from psychology and human experience that that's not typical? People don't typically lie about their dreams. So the odds aren't 50-50. Like, you have a lot of information that people just don't usually lie about their dreams. Like, they're usually telling the truth when they say they had a dream. And so you have to use that information, that evidence, for your prior odds. You can't just ignore all of that evidence as, well, I'm going to say it's 50-50 because I have no specific evidence in your case. No, you have to go with the prior odds until you have specific evidence in your case to change those odds. And that's how all sound empirical reasoning works. It's how all science works. It's how history works, and so on. And so Bayes' theorem just explains why that's how it works, basically.
Okay. Have you run across any misuses of Bayesian logic?
Yes. In the hand, yeah, a lot, actually. But to be fair, the same as with straightforward syllogistic logic. Like, there's tons of misuses of straight up logic, right? And it's important to note that, if some Christian comes along and abuses logic, that does not discredit logic. You don't say that, oh, well, logic is useless because look what they did with it. No, you just say they're misusing the logic. If you use it correctly, that you couldn't get the result that they're doing. It's the same with Bayes' theorem. If someone misuses Bayes' theorem, that doesn't discredit Bayes' theorem. It discredits them. They're misusing the theorem. Right. And I give examples in the handout. In the handout that's attached under File. If people haven't grabbed it yet, they should go into Files on the right and grab the handout, download it. One of the articles I link in there is my article on Swinburne and Unwin, who I use as classic examples of abusing Bayes' theorem, using it wrong, incorrectly, and I show how they use it incorrectly and why it's incorrect. And once you correct for their errors, their conclusions flip the other way, which is another example of how they're attempting to argue for the existence of God using Bayes' theorem, but when you fix their mistakes, the Bayesian argument actually ends up producing an argument against the existence of God rather than for the existence of God. And so that's the key thing. When people misuse it, just correct them and then see what happens when you correct everything that was done wrong. Then what does the result come out to be? And it's often not the result they want.
Now, is that the most common type of misusing Bayesian theorem? Is just entering the numbers in wrong, or are there more common misuses?
Well, it's not just entering the numbers wrong; it's leaving things out, right? So you might say that the prior, or it could be, there's lots of ways you could say the prior probability is such and such when you have no evidence backing that prior probability, or you can say that the evidential odds are such and such, but you're leaving out evidence that if you put it back in would completely change that equation. So it's usually when they're abusing Bayes' theorem, they're doing the same thing they do when they're not using Bayes' theorem. They're just dressing it up in the uniform of Bayes' theorem to make it look fancier. But it's the same mistakes they always make. It's the same errors always. They're always leaving evidence out. They're drawing conclusions from an isolated selection of evidence. They're not actually doing the math of figuring out how likely is the same evidence on the alternative explanation. They're not taking the alternative explanation seriously. There's lots of things that they're doing wrong that they always do wrong, whether they're using a Bayesian argument or not. When they misuse Bayes' theorem, all they're doing is encoding those errors in a Bayesian format. It's just another way of writing the same mistake in a different language. It's still the same mistake. And that's an important thing to notice. Bayes' theorem can help you find those mistakes. It's more easy because they're giving you the structure where you have three numbers. Their whole argument is based on three numbers. So you just have to figure out how did they get those three numbers and are those numbers valid? Super easy to vet an argument when it's that. But whereas if it's like a 10-page argument in colloquial English, it can be really hard to figure out like where the argument's going wrong or even what the logical structure is or what you should be criticizing, what you should be checking. they put it in the Bayesian form, it's super easy to vet and check their argument because they've just told you what they're arguing. And so now you can actually check those things directly. And that's one of the big uses of Bayes' theorem, that you can diagram an argument and then figure out what's wrong with it or why it's right.
Interesting. One of our attendees, Thomas Baer, asks, what was your inspiration for turning to activism?
Oh gosh, that's a long time ago. That's my Coast Guard story. So I tell this story when I was in the military. I tell the story in my book, Sense Goodness Without God. So if you want the full story of how that happened, I go through my upbringing, and then because I was not particularly anti-religious, and I didn't think religion was a problem. I knew there were like these conservative, fundamentalists, and that they were silly and had bad ideas and harmful ideas and stuff. But it wasn't until I became an adult, a voting citizen, and started running into the fact that they actually run everything, and that votes and decisions and laws are occurring that are actually affecting lives based on these ridiculous beliefs. Then I started to get more angry and more interested in like opposing religion, because it was getting in the way of all social justice, getting in the way of all progress in welfare of humanity. And I got, by the time I'd ended up, I was a Taoist at this time, by the way. I wasn't an atheist. So I thought Taoism was the true religion and the solution to all of this. Eventually I became an atheist, a naturalist atheist in the Western tradition. And that was, it was in the military, and then by the time I'd left the military, I was full-on involved in activism and getting more involved with the secular web, eventually, which was used to be, it still is, a warehouse for writings. It used to be the main warehouse on the internet, the go-to place. Now the internet has exploded in huge size, and you can find stuff everywhere. But back then, it was the main place for finding atheist arguments, criticisms of religion, and so on. So for me, it was always trying to get people out of or away from these toxic ideologies that are leading people to make bad decisions that are hurting other people, hurting society. And so that was the main motivation at that time. But it came late in life, right? So like I was already an unbeliever, because as a Taoist, there's not a God in Taoism. So I was technically an atheist, but I wasn't a naturalist atheist. Still kind of a supernaturalist at that time, a little bit. And so I didn't come to it from being raised in a particular tradition. I actually was raised in a fairly nice liberal Christian tradition that's why I didn't think religion was a problem. And it was only after I became an adult and gotten into the world that I started running into fundamentalism and realized it was a problem. And then got busy fighting it. And the best way for me to do that is as an intellectual, to get critiques out there, get information out there that people can use and spread, to basically provide the ammunition for people to load their artillery with. So that's how I see my role, was a support role of providing ammunition and help for people to defeat religion.
That's wonderful. Thank you so much for sharing that. So is it possible that there's simply a distinction between what ought to be considered evidence for in terms of natural cases versus supernatural cases? So is it possible that a religionist could argue that claims of the supernatural or claims of religion require a different type of evidence or no evidence at all?
I mean, it's logically possible. It all comes down to that probability. It's like whatever you're calling evidence, doesn't matter what it is, how likely is that if there's a natural cause rather than a supernatural one, and vice versa? It's the same question. So it doesn't matter what you're calling evidence, you still have to ask the same question about it. And I find usually when they try to come up with, we need a different kind of evidence, what they come up with is stuff that actually is just as likely on naturalism as on theism, or it goes the other way. Like the argument from religious experience, for example, actually ends up being an argument against supernaturalism and God. And for people to see how that happens when you put evidence back in that you left out. That's in my counter apologetics article that you can find a link to in the handout. And I have that argument in there, and you can see that actually when you put evidence back in, it goes the other way. And so that's usually what happens with these arguments. The argument either collapses or ends up reversing. And this is where I realized that counter or apologetics is all about hiding evidence or ignoring evidence or trying to pretend it doesn't exist. It's all rationalizing, trying to find the evidence that I want that gets the result I want, and ignoring all the evidence that goes against the result I want, or making up excuses to ignore it. And that's a desire-driven belief system where you're rationalizing your belief rather than testing your beliefs. And we need to turn ourselves into belief testers, including our own beliefs, not just other people's beliefs. We need to be belief testers rather than belief validators, belief rationalizers.
Now, when you argue that Jesus was likely not an historical figure, an actual physical human being who lived in the first century Palestine, did you come to this conclusion using Bayes' theorem?
I did. My conclusion in the peer-reviewed monograph that you put up earlier is that there's, at best, a 1 in 3 chance that there was some sort of historical Jesus, which is actually respectable odds. Like 1 in 3 chance is not that low. So there could well have been a historical Jesus. I just find that the evidence sort of leans the other way. That the evidence, there's a lot of improbable things about the evidence, unless Jesus started out as a revelatory being and got inserted into history later, as had been the case for many other gods. So it's not even an atypical outcome. Like, this happened a lot. There were non-existent gods that people communicated with spiritually that later got inserted into history as historical people. Like, that happened all the time. So the question is, like, well, why should we think Jesus is the exception to all these other myth men, these other god men that the same thing happened to, that they started out as celestial beings or mythical or spiritual beings and then were inserted in history later? Why is Jesus the exception? And when you go looking for evidence that Jesus is the exception, there really isn't any. It all falls apart when you look at it. And that's what I examine in the book. I take a serious look at the most reasonable theory of historicity, which is not the Christian theory, but it's the mainstream secular ideas of a mundane historical Jesus, and compare that with this alternative theory of how things happen, and see which one of those things makes the evidence more likely, which one of those things explains the evidence better, and that requires looking at all the evidence. And so that's what the book does.
I think that is it for questions.
Cool.
Yes, wonderful. Thank you so much, Dr. Carrier. I really appreciate this. This was such a fantastic presentation and a great breakdown of Bayes' theorem. So I want to say thank you to everybody in attendance today. And yes, all these presentations will be recorded so that you can watch them at a later time. We will send you the link to these things afterwards. But thank you for attending.
Yeah, thank you, everybody.
I hope I'll see you later this afternoon. And Dr. Carey, I want to give you the last word. So,
oh yes, well, thanks everybody for listening in. Like I said, check out my website richardcarrier.info to learn more about this stuff. Look at the handout; it has useful info in there, and then take my courses. It helps support my work, my continuing work, as the intellectual support matrix, helping out people defeat religious arguments, amongst other things, not just religion. But